There are lots of benefits for using XML-based configuration files. The first thing is that they're human readable and accessible. Well, as long as you consider XML to be human readable. But you need to have at least a basic understanding of how XML works. The old ASP metabase in IIS was binary and accessible only through Windows tools. Configuration settings are easily viewed and modified using either graphical tools or a text editor. You have a lot of flexibility in how you make changes to these. When you do make changes to the settings, ASP.NET by default automatically detects the changes and makes them immediately effective. It does this by creating a new application domain and redirecting existing users when they make new requests to the site to that new app domain. Any requests that are in process continue to be executed by the old app domain until they are all fulfilled. The Configuration API in the framework provides a complete infrastructure for configuration settings, so you don't have to write your own code anytime that you need to step outside of what the configuration files within the .NET framework will do for you. That also means that the system is extensible, so you can add additional settings as needed for your application. From a security standpoint, configuration settings are protected from viewing by unauthorized users, and you can even automatically encrypt sensitive settings. When you're ready to deploy the site, you can easily copy configuration files to other machines and web applications without having to apply settings to a binary store. This really simplifies the process of moving your site from development to testing to staging to the final production server. The configuration system within the .NET framework is hierarchical, and you can navigate around it, and you have a lot of flexibility in how different settings are applied to different contexts. All ASP.NET applications have at least 2 configuration files that provide settings, and most applications have at least one more. The root machine.config and web.config files contain machine-wide settings. Changes that you make to these files apply across the entire application server. And then you can have an application web.config file. Any settings that you make here, in most cases, will override the settings in the machine-wide configuration files. We'll talk more a little bit later about how all these configuration files fit together. But the important principle to understand is that lower settings in the hierarchy override those higher. So any settings in the application web.config files override settings in the root web.config file, which override settings within the machine.config file. You also have the flexibility within a single config file to use a location element. And we'll cover that a little bit later as well. So let's talk a little bit more about these machine-wide configuration files. The machine.config file is the parent configuration file for all .NET applications that run on this particular machine, and that includes all ASP.NET files. So no matter what .NET code you execute on this particular machine, in most cases we're talking about a web server machine, it's going to apply to all of those settings. So this is where you would want to make any changes that you automatically want to have apply to all applications. This is a very common scenario in a web hosting situation where you want to set, for example, the trust level of all of the applications hosted there to a little bit lower level to protect each application from itself, because each application may be developed and uploaded by different people. If you've worked with configuration files in versions before ASP.NET 2.0, then there were some changes to the machine.config file. It used to be that machine.config was the be-all and end-all of the machine-wide settings. But in version 2.0, Microsoft split that out. So now there's a machine.config, which is still the ultimate root configuration file, but then there's also a root web.config file that has the settings for all ASP.NET applications. This just makes it a lot easier to make changes that apply only to web applications. But that root web.config file is located in the same directory as the machine.config file. And this resides in the config directory where the .NET framework are installed, which is typically within the Windows directory on the C drive. So let's take a look at how these files are structured and where they're located. Here I have Windows Explorer open to the config directory within the directory where the .NET Framework files are located. So you can see that I have a machine.config and a web.config file. So these are installed as soon as you install the .NET Framework, which is also installed along with Visual Studio 2008. Notice that these are located in the Windows directory on this particular machine, subdirectory Microsoft.NET, the Framework directory, version, and the config directory. There's a couple other things to notice about this. Both the machine.config and the web.config file have 3 different versions of the file installed. The .config files are the ones that actually contain the settings that are in effect when you run any .NET or ASP.NET application. The comments file is the same default contents as the machine.config or the web.config, but it's commented so you can get some information about the individual settings. And then there's also a default file. This is essentially a fallback file. If you make any changes to machine.config or web.config and decide that everything is just completely messed up, then you can delete the web.config or machine.config and just copy over the default file, because this has all of the default settings for the applications. As I mentioned earlier, in older versions of the .NET Framework, machine.config was the be-all and end-all of system-wide configuration settings. If a setting applied to all .NET applications, you set it within machine.config. But ASP.NET applications are a special subset of .NET applications, requiring their own settings that are often overridden by application-level settings. So to keep things better organized, beginning in ASP.NET 2.0 and continue forward in ASP.NET 3.0, Microsoft partitioned the ASP.NET specific settings into a root web.config file. It's located in the same directory as machine.config, as you just saw. Machine.config is still the root configuration file, and then the root web.config file overrides any settings. But as a practical matter, what it does is it segregates out most of the ASP.NET specific settings. So it's the next step down the hierarchy, and as you're going to see shortly, you can get pretty deep down into the hierarchy with various configuration files. So it inherits settings from machine.config, and these settings do things like register core HTTP handlers and modules, set up rules for browser support, and define security policy, and a whole lot more. Each ASP.NET application inherits default configuration settings from the root web.config. However, you can continue to override and extend the settings in an application web.config file. Now, there are some settings that you can't override. For example, the process model element in machine.config configures settings on a Microsoft Internet Information Services web server. This affects all ASP.NET applications that are running on the server, and you can't override those settings within individual applications. The next level down in the hierarchy are application web.config files. So the hierarchy starts at machine.config, then is overridden by root web.config, and now we're talking about the application web.config file, which overrides any settings within the root web.config file. The settings within this file apply to the current application only. If you want the same settings to apply to another application, you need to duplicate the web.config file and put that new file in the root directory of that other application. So you can continue down the hierarchy with web.config files in various subdirectories, and each web.config file controls the behavior of the pages that are contained within that subdirectory, as well as any subdirectories of that subdirectory, as deep down in the file system as you care to go. So when you run your ASP.NET application, the Common Language Runtime computes the configuration settings hierarchically, starting again at the top of the hierarchy with machine.config, going to root.config, going to application web.config, going into subfolder web.config files. This provides lots of flexibility and control to partition groups of pages. So for example, say that you have this directory structure. Here's how the settings will be applied. First, it reads the settings from machine.config. Then it reads the settings from the root web.config. Then it uses the settings from the web.config file in the application root directory. And then it applies the settings from the web.config file in folder 1. And then finally it applies the settings in the web.config file in folder 2. For example, say that you have a set of administrative pages on your site that only members of the site's administrators group should be able to access. You can put those pages into a separate subdirectory and set authorization rules in a web.config file in that subdirectory. Those rules then apply only to pages in that subdirectory, so you have effectively partitioned the rules to apply to a subset of all pages in the site. Well, as you can imagine, you could very quickly end up having a very complex hierarchy on disk, many folders, each with their own web.config file. This could really make things very quickly very confusing. And it can become unwieldy to maintain all of those files. So ASP.NET provides an alternative means to the end. You can use a single web.config file in the application root and then include one or more location elements with the path attribute set to different subdirectories within your application. When you use the location element like this, you can apply configuration settings to specific folders and files from a single web.config file, which makes it much easier to maintain the overall settings for the entire application. And the path attribute is the important part of that location element, because that's how you specify the specific file or child directory to which the configuration settings that are defined within the location element apply. Keep in mind that only one file path can be used in the path attribute, and the location element takes precedence over any ASP.NET configuration settings in the current web.config file. This shows a subset of the web.config file that is located in the application root directory. The root directory has its own configuration settings, whatever you might choose to include. But then you can specify different settings for the child 1 subdirectory. And you specify that using the location element and the relative URL of the path to that child subdirectory. Then you specify within the system.web element any custom settings that apply only to the child 1. The overarching principle at work here is that the closer a setting is to the pages it affects, that is the setting that is going to actually apply, because the setting within a location element that applies to a child subdirectory is going to have a higher precedence than a setting in the application web.config, which has higher precedence than the root web.config, which has higher precedence than the machine.config. Hopefully you're getting an idea of how the hierarchy works for these configuration files. Configuration files are defined as a set of XML elements that implement configuration settings. The contents of the XML file has to be well-formed XML. The XML tags and attributes are case-sensitive, and they use a rigid schema, so take care when you edit them to use the correct casing. The configuration element is the root element in every configuration file, and every configuration file must have a configuration element. And then there are a number of child elements that can be contained within the configuration file as well. The config sections element exists primarily in the machine.config file, where it defines the sections and section groups that appear there in an all-child configuration file. The .NET Framework makes heavy use of these different config sections to give you standardized access to various settings. The App Settings element contains custom application settings, such as file paths, XML web service URLs, or other information. App Settings also contain optional add, clear, and remove elements that allow you to add, clear, and remove references from the collection of settings within this element. The Connection Strings element lets you specify a collection of database connection strings as name-value pairs. In earlier versions of the .NET Framework, you would typically just put connection strings within the App Settings section, but this was being used so often for a specific type of data that Microsoft broke it out into its own section. Connection strings within a parent configuration file are inherited unless you use the clear element within a child configuration file. We'll talk more about configuring connection strings a little bit later. And then the location element specifies the resource the child configuration settings apply to and can lock configuration settings, preventing child configuration files from overwriting them. The System.Web element acts as a container for the predefined ASP.NET settings. As you're developing an ASP.NET application, you're likely to spend a fair amount of time in this System.Web section in order to configure the settings for your application. It contains various elements that configure web applications and control various behaviors. The System.Web element is a child of the configuration element. The System.Web element itself in turn has various child elements. For example, the authentication element determines the authentication scheme that allows users to get access to your application. Similarly, the authorization element controls how different users and groups can get access to the various resources of your site. The compilation element configures all compiler settings, how your language compiler actually compiles the code behind the page. Custom errors provides a way to specify default and error-specific pages, so that when something goes wrong with your application, you can redirect users to a page rather than accept the rather ugly default error page that ASP.NET provides. The sitemap element configures support for the navigational infrastructure of the site. And trace lets you configure how trace results are gathered. Trace is a way of debugging applications as you're running them within a browser. You can use URL mappings to configure a user-friendly URL, hiding the real URL. This is a particularly useful technique if you're doing any kind of search engine optimization. Session state configures the state settings for the current application, how you save different pieces of information associated with each user of the application. And then the web services element controls configuration options used for web services. Let's take a look at how a web.config file is put together. Here's the web.config file for the sample application. I'll go ahead and make it full screen to make it a little bit easier to see the different sections. There's a lot to this file. I'll just point out a few of the more interesting features. So first of all, as I mentioned, the configuration element is the root element for all config files. Here's an app settings section where you can specify any basically random key value pairs of information, data that is used by the application. In other development environments, you might hard code this in the application code. But here what you can do is you can specify, for example, a page title and give it a value that is read at runtime in order to customize how a page appears. The benefit of putting this in a config file is that you can change this value without having to recompile the code of the application. So if you decide later that you want to put in programming the web.config file, you can just open up this file with a text editor, change the value there, save the file, and ASP.NET automatically finds out that there's a change made, and then all new requests pick up the change, and it customizes the appearance of the page. That's just one fairly simple example of the myriad uses that you might find for the app settings section. Here are a couple examples of connection strings. So I have a couple of connection strings that access different databases for use within this application. The Northwind SQL connection string will connect to a local instance of the Northwind database running on SQL Server or SQL Express, and that defines how the application accesses the database. This particular application also makes use of an access database located someplace on the local hard drive, and this is another connection string that at runtime the application can read in order to open that database. Here's the system.web element. So this is going to configure various behaviors for the application. One thing you should do in most applications is provide custom error handling. If an exception occurs within your code or within ASP.NET, and if that exception is not caught, you can define that the application should redirect to a custom error page. Here's the compilation setting. In this particular example, we just have one attribute set, which is that anytime we run this application from Visual Studio, we want to debug the application. Here's the element that indicates that we're using Windows authentication for this application. We can allow impersonation. This is a way of performing an operation using a security context other than the one under which the application is running. A pretty advanced security technique. So as you can see, there is a lot of settings within this web.config file. You'll want to spend a little bit of time exploring your own application web.config file so that you get a feel for how it works, to make it easier to find the settings when you need to make them within your own application. But fortunately, there are easier ways of making changes to settings. ASP.NET provides several tools as well as a programmable API that makes it easier to create and maintain configuration files. These tools are preferable to a text editor or even editing the XML directly within Visual Studio because they include error detection and help you configure the files correctly. But as with most tools in .NET, ultimately all you are doing is editing text files. Use whatever tools best suit you. One of the tools is a website administration tool. It's a user-friendly graphical editing tool for changing a lot of the more common configuration settings that you'll need to make for your application. It's browser-based that you start from within Visual Studio. And a nice thing about it is because it's browser-based, you can change website settings remotely, as long as you have the proper permissions to do so. This is a real handy technique for administering a site that is already deployed to a production web server, particularly if it's a hosted web server that you don't have direct access to Windows. The website administration tool is installed automatically with all of the versions of the .NET framework from version 2.0 and later. Another tool you can use is the ASP.NET MMC Snap-in. This allows you to manipulate ASP.NET configuration settings at all levels on a local or remote web server. It appears in the IIS Manager as an ASP.NET tab on the property sheet of a website or virtual directory. The .NET Framework also includes various command line tools that perform specific configuration options. For example, ASP.NET_REG_IIS lets you specify which version of the .NET Framework applies to a particular ASP.NET application. ASP.NET_RegSQL configures a database for storage of various ASP.NET data, such as users and roles or session state data. If none of the tools work for you and you really just don't want to work with the XML directly, you can program against the ASP.NET Configuration API. This is actually an API that is available through all .NET applications. It's a complete managed interface for configuring applications without directly editing the XML configuration files. One really nice thing about the API is that it provides a merged, integrated view of the data from all levels of the configuration hierarchy. What that means is that when you read a setting using the Configuration API, it is the setting that actually applies to the current application. You can also extend the schema and define new configuration parameters and section handlers if you need to go beyond the capabilities of the configuration files as Microsoft defined them. If you spend a lot of time thinking about security, you may be concerned about all of this information that is stored within a configuration file. For example, say you had to put a connection string to a database within a web.config file, and rather than using Windows Integrated Security, for some reason you had to use a SQL Server login. In that case, you need to put the username and password for the database right there within the configuration file. That potentially could be a security hole, because if an attacker can get access to that config file, then he or she might be able to get access to the database. Fortunately, the .NET Framework and Common Language Runtime provide a number of security features that protect the contents of config files. ASP.NET configures IIS to deny access to any client browser that requests access to the machine.config or web.config files. If a user tries to access those files directly by putting them into the URL, they'll get an HTTP access error 403 forbidden. So that protects the contents of those files. If you have particularly sensitive information, you can encrypt various sections of the configuration file using protected sections. Configuration files in one ASP.NET application cannot access configuration settings in other ASP.NET applications unless the application is running in full trust under an account that has permissions to read the configuration file in other applications. This is a really useful feature for shared hosting environments, but it's also useful in a situation where different departments in a company need to protect their data from other employees within a large enterprise. By default, the access control lists, or ACLs, within Windows are set for the ASP.NET or network service accounts so that they can only read and execute the root machine.config and web.config files. That means that your application by default is not able to make any changes to those files. So that's a nice bit of protection so that a rogue application can't get access and update the settings to mess up all of the applications running on that machine. The website administration tool has special permissions such that you can use it to modify configuration files. It runs essentially with the security context of Visual Studio, which is actually a desktop application. But if you want to modify configuration files programmatically, the application should be running under an account that grants the necessary ACL permissions in order to access and update those files. Now I'll describe how you can modify the configuration files using the Website Administration tool as well as the ASP.NET Configuration API. As I mentioned, the Website Administration tool is an alternative to manually editing configuration files. Most of the changes to the configuration settings that you make in the tool take effect immediately. So if you're doing this to a deployed website, it means that the application is going to restart. However, there are some parts of the tool that display a Save button. In that case, you need to click that button before the changes are actually saved to the config file. And if you leave the page without clicking the Save button, your changes are lost. So pay attention to the buttons that are available within the tool. The tool manages only a small subset of the most common configuration settings that are available to the website. There are still many other settings that require direct modification of the configuration files, either manually or using another tool, or programmatically using the ASP.NET Configuration API. But the tool provides a really nice graphical interface that takes care of setting a lot of the most common configuration values in order to set up your web application. So let's take a look at the tool. There's a couple different ways to open the Website Administration tool. You can select Website and ASP.NET Configuration, or you can come over to Solution Explorer and click on this icon over here. That's how I'll open it. So that loads the default browser, and now we're in the tool. In addition to the Home tab, the tool has 3 tabs. The Security tab lets you set up and edit users, roles, and access permissions for your site. Application Configuration, or just Application up above, lets you manage your application's configuration settings. And the Provider Configuration lets you specify where and how to store administrative data that your website uses. Let's look at each of these tabs. I'll click on the Security tab here. This tab lets you manage the security settings for your application, such as configuring users, passwords, roles, and permissions. By default, this information resides in a SQL Server database located in the App Data folder of the project. You can access that database using SQL Server or SQL Server Express, which is included in a full install of Visual Studio. Or you can configure a different provider over on the Provider tab. There's a couple different ways to use this tab. You can either use the Security Setup Wizard to configure a bunch of settings all at once, or you can click on the individual links down below to set up and manage different applications. And as you establish different security settings, the number of links available will change down below here. Over on the Application tab, lets you configure application-specific settings that you don't want to hardwire into your application code or pages. You can do things like configure application settings, configure SMTP email settings, set debugging, tracing, as well as a default error page. You can also take the application offline. Finally, the Provider tab lets you configure storage of website management data, such as membership users and roles. You can use a single provider for all the management data for your site, or you can specify a different provider for each feature. In this particular case, we're currently using the default ASP.NET SQL provider, which means that we're using that SQL Express database within the app data directory. Let's start to look at how we can make various changes to our configuration files. One of the big improvements in .NET is the ability to provide a unified error handling architecture. That includes declarative custom error handling and works the same way in all .NET programming languages. In ASP.NET applications, that means that you can automatically log errors, write to the Windows log event, send email, or redirect users to custom error pages whenever an error occurs that is not handled within the code itself. This is a really good way to provide a good user experience and prevents the user from seeing any kind of error and exception information. It also gives you control over the message and display pages that are friendlier than the default ones. And the Website Administration tool automates the process of configuring these custom error pages. To show how to do this, I'm going to go back over into Visual Studio, and I'll rename the web.config file to some other name. I get a warning saying that if I change the extension, the file may become unusable. Well, that's exactly what I want. So I'll come over here to the website, I'll add a new item, and I'll select Web Configuration File. This is how you can add a web.config file to any application that doesn't currently have it. The language setting doesn't make any difference whatsoever, so I'll go ahead and add the file. So this adds a default web.config file to my application. Now I'll go back over to my web configuration tool. I'll go to the Application tab, and I'll click on the Debugging and Tracing link. I'll go ahead and enable debugging. Next, I'll scroll down to the bottom of the page and click on the Configure Custom Error Pages link here. Notice that it's set to use the default error message. That's sometimes called the yellow screen of death because it displays a default page with error information that has a lot of yellow to it. We don't want that, just doesn't fit into our website theme, just isn't a very friendly interface. So I'll change the setting, and I'll specify that I want to use the custom error page.aspx. This is an existing page within my application, but by making the change of the setting, it now tells ASP.NET that when there's an unhandled exception in the application, it's going to display this custom error page.aspx instead of the default error message. Notice that when I selected the specify URL to use as the default error page, it posted back and made that change immediately to the web.config. But to save the change to specify the custom error page.aspx file, I need to click on the Save button. So I'll go ahead and do that, and I get the message saying that the default error message setting has been saved. I'll click on OK. Now I'll go back to Visual Studio, and notice that I get this dialog box saying that web.config has been modified outside of the source editor. Do I want to reload it? Well, of course I do. I made changes to it and I want to see them. Notice that it added the debug attribute to the compilation element and specified true. That was that first checkbox that I checked. And then it added a custom errors element here with a default redirect to the custom errors page. Now, even though the tool created the custom errors section and set the default redirect to point to the page that I selected, it didn't actually activate it. To test this, I'll go ahead and press F5 to run the application. There's the default page, and I'm going to put in a request for a non-existent page. I'll just call it something creative like xxxxx.aspx. And I'll hit Enter. Oh, wait a second. I'm still getting the default ASP.NET error page. Okay, the reason for this is because I haven't actually activated that redirection to the page. So I'll go ahead and close that browser instance. In order to activate it, I have to add the mode attribute to this element. There's various settings, but I'll set it to on. And it actually has to be proper case. And I'll save that file. So that determines whether or not the redirection actually takes place. I'll press F5 once again to run the application. I'll select my xxxxx.aspx page, hit Enter, and now we get this custom error page. Okay, so it's not exactly a big improvement upon the other one. But the point is that you do have a custom error page. You can format it, add styles, do whatever you want to it to make it look like a page that is part of your web application. A very useful technique and very important for making a website that is user-friendly. One thing to keep in mind is that if the custom page itself causes an error, then you'll still get the ASP.NET default error page. So just make sure that you don't write any code in this page that can cause any kind of exception.